Ms. Hall,
And Miss Nelson.
and today we're doing constant rate of change with graphs. Friday we did, or actually Wednesday, Thursday, your homework was with tables, and now we're doing it with graphs. So what you're going to do is you're going to look at your graph, and using your ordered pairs, you're going to fill out a table. So once you get your information from the graph, you create a table, and then you do it just like you do with tables. So we see we have 0, 0. So that, and remember, this is your x and this is your y. So we have 0, 0. And we talked briefly in our notes that a graph, in order to be proportional, had to go through 0, 0 and be a straight line. So we already know that this graph is in fact proportional. Now I'm going to use where it crosses exactly. So if you notice this, your x-axis is numbered in ones. And so we're going to go 1 and up 2 squares, which actually the y-axis is numbered in 8. So this is going to be, this dot right here, point right here is going to be 1, 8. Then I'm going to go to 2, 16, which is this dot here. They actually have that one marked. And then we have 3, 24. And for this, the very tip of the arrow would be 432. So now we have that filled out. We're going to look at our change in x. And as you can see, our change in x is +1 each time, and it is consistent. And our change in y is +8. And it's also consistent. So let's answer our questions that are over here in the box. So we're going to answer, let's read the example. I didn't do that first. The graph represents the amount of cheese a chef needs and the number of pizzas being made. Determine the constant rate of change by writing the information given from the graph into the table. So if you notice, your x-axis is number of pizzas and your y is cheese. So for every 1 pizza, you need 8 ounces of cheese. But what does this 0, 0 point mean down here? That means 0 pizzas. If you have not made any pizzas, you don't need any cheese. So 0 pizzas have 0 ounces of cheese. The point 324 represents 3 pizzas have 24 ounces of cheese. So now we're going to calculate our constant rate of change from the table. We took the graph, we made a table. And so our change in y over change in x is always how we find constant rate of change. And our change in y was 8, our change in x was 1. So our constant rate of change is 8, and our equation is y equals 8x. Okay?
So if we look at the next piece, it says, if a line goes through 0, 0, then the relationship is, okay, so we already know that anything that goes through 0, 0 is proportional. Okay, if the relationship is blank, then the constant rate of change is also called the constant of proportionality. So again, if the relationship is proportional, then the constant rate of change is called constant of proportionality, okay? So basically what this means is when you write the equation, the y equals 8x in our example above, or we call it the y equals kx, or k equals y over x, that's how you find the constant of proportionality. As long as there is just a constant rate of change with the x, then you know that it is proportional, and we call this constant of proportionality. Basically, you're naming the same thing several different names. So let's look at number 2. It says the graph shows the cost versus the number of oranges purchased. So is the relationship proportional? How do you know? Then we're going to be solving everything. So if I come look over here, I know number of oranges. That is my x-axis. This is my y-axis. So in my table, I'm actually going to label it. I know it's x and y, but a lot of the times you'll see labels and they won't give you an x and a y, especially if you have a graph and you're expected to know which axis is which. So I'm going to label this number of oranges, and I'm going to label this cost. Okay, so now let's go to our table and our graph, and let's start finding points. So I know if I'm following my line, the first point that it meets exactly is right here. If I keep following my line, it hits again right there. If I keep following, it hits again right there. Okay, it does hit other points, but they are not an exact cross between the x and the y-axis, so therefore it's going to be decimals and fractions, and that makes it a lot harder to work with. So when I fill in my table, my first point, it was 3 oranges, and that cost me $1. And then 6 oranges, and that cost me $2. 9 oranges, and that cost me $3. Okay, so we're going to go back to what we know how to do. And Ms. Hall just pointed out to know if this relationship is proportional. So you don't even have to do any work for that. If I look back here on my graph, because it crosses at 0, 0, then I'm going to say, yes, my graph is proportional. And how do you know? I'm going to say the line crosses through, and I'm going to use the graph 0, 0. Okay? So let's go to our table and let's find our change in x, change in y. So my x's, I am adding 3 each time. My y's, I am adding 1. So change in y over change in x. So my y is a 1, my x is a 3. Okay, and it is okay to not get a whole number. It's okay to have this. So find the constant rate of change from the table. Well, I know that if my constant rate of change is 1 over 3, okay, this is the first time we've seen a fraction, and it says, what do you notice? Use the information to write the equation. So let's go back to what do we notice? I notice that my rate of change, is a fraction. Okay, which all that means, again, is the relationship between your x and the y. It's okay to have a fraction. It's also okay to have a decimal. So to write the equation, I'm not going to change how I've ever written it. I still start with y equals. And all I do is take that rate of change of 1/3 and I just attach it to the x. Again, it is okay to have a decimal or a fraction. You do not just have to have a whole number. What this actually means is that for... What this actually means is that I would go up 1 and over 3 each time, okay, which is why it's the change in y over change in x, and you'll hear us refer to it as a couple of other things as we keep going.
Especially next week as we get to slope-intercept form, which is y equals mx plus b.
Yes.
Okay. On the back, flip up to the back, we have our third example. The table and graph below show the cost to rent a bicycle at 2 different stores. Which store charges more per hour, and explain. So we're going to, so it gives you pedals rentals, which is a table, and super cycles, which is a graph. So let's go ahead and with super cycles, let's make a table. Okay, so we have number of hours, how did, 0.5. Okay, if you notice down here, they count in increments of halves. And so I'm going to look, this is 0.5, and let me get a different color, and 4. So I have my x and my y, and your x is your hours, and the y is the cost. okay? So for 0.5 hours, it costs $4. I'm going to go to the next one, perfect one that changes, and it is 1 hour, and it is $8. Then I have 1.5, hold on, 1.5, and it's 12. And then I have 2, which is 16. Okay, so now we're going to find our rate of change. Notice they actually have, they showed you here that the, it actually goes up and over for you, and like Ms. Nelson just showed you, the rate of change, it goes up, let's see, 8, 2, 4, 6, 8. So change in y is 8 over 1, okay, which is 8. But we're going to do that mathematically over here. I'm going to use my whole numbers just so I don't have any fractions. So if you notice here, when I go from 1 to 2, that's a plus 1. And when I go from 8 to 16, that is plus 8. Change in y over change in x is 8 over 1, which is 8. So is this proportional? Yes, it's proportional. It goes through 0, 0. Find the constant of proportionality. We already did. It is 8. And the hourly cost of supercycles is $8. Okay, let's go back over here to our table. They already have a table for us. And our change in x is 1. Our change in y is plus 12. Is it proportional? Yes. For 0 hours, it cost us $0. If we went backwards, find the constant of proportionality. We have change in y over change in x, which is 12 over 1, and that is 12. So the hourly cost of pedals rentals is $12. Okay, so what can we conclude from that? Supercycles is $8 an hour. Pedals rentals is $12 an hour. So pedals is more expensive. So I'm going to just write a sentence, use our words. So pedals rentals charges $4 per hour more than supercycles.
And all she did to get that was just subtract the 2 rate of changes. 12 minus your 8 equals the 4 that she got. You could also flip it the other way and say that supercycles is $4 cheaper than pedal rentals. Both of those are acceptable answers.
Remember, we always say we don't care how you do it as long as your math is correct. And usually with math, there is more than one way to do it. And that does not mean that that's incorrect. It just means it's different. Okay, make sure you glue this into your journals and come tomorrow if you have any questions to class.
Bye.